Unit 5, Part 10. Okay, let's go ahead and do 3D. We've been talking about the short truth table method for the last two parts, parts 8 and 9. Continuing on, we'll do 3D now. What are we doing? We're testing the argument form for validity. How have we started? We've assigned the truth value true to all the premises and false to the conclusion. Right, that is putting a T under the major operator of all the premises and a false under the major operator of the conclusion. Now, it is not going to turn out the same for every problem, that is for every short truth table method problem, that the order in which truth values appear, the order in which you discover the truth values you need for your counterexample, assuming you can find one, it's not going to be this one, then this one, then this one, right? You don't look to assign a truth value to P and then to Q, then to R, right? It might be, and it will be in this case, that the truth value for T appears first, and then maybe this, maybe that, right? What you have to do at this stage, after you've made that initial assignment, is ask yourself, right? You have to look at the actual structure, think about the truth table for these operators, right? The truth table for hook, truth table for this, right? Think about that and ask yourself, which sentential variables have their truth value determined by the assignment I've just made, right? And that thought you're going to reiterate, okay? Because you're going to make some assignments, some things are going to appear here, and then you have all the, say you have you discover that the T has to be false, as we will, and I'll say why, but then once you have discovered that if I'm going to get a counterexample, it is determined that T has to be false, the sentential variable T has to be false. That means it has to be false everywhere, so I'll put a T here as well, say. And then you'll ask again, what follows from that? Which sentential variables, again, have their truth value determined by the move I just made, by the assignment I just made, okay? So it's very important you be very, this technique, this short truth table method, is a very good test, very good test of the thoroughness of your knowledge of the truth tables, the basic truth tables for our operators, right? You need to be very familiar with them, very familiar with the shortcuts, right? Very familiar which ones have most of their values true and some false, and say one false, or which ones are only true under one condition, and so on. For example, if you have a premise, right? Say you had a premise, remember the premises have to be assigned true, which was P and Q and R, right? Which is not part of this one, but if that was your premise, then you would start there, right? As it happens, I'm actually going to start on 3D with the conclusion, and I'll explain why. But if your premise was a conjunction where one of the conjuncts is itself a conjunction, say, you would, knowing thoroughly the truth table of the dot, right? What have I said? I've said all premises have to be true, so that's the major operator, that's true. What does that mean? That means it is determined that R is true. It's determined because a conjunction is true only when both conjuncts are true. R has to be true, right? It is not possible for this formula to be true without R also being true. So I'll be able to write down right away, like R is true, if that was my premise. And I would start with a premise because it yields for me determined truth values for not only this variable, but also these ones, right? That this has to be true, and this second, the left conjunct has to be true. It's itself a conjunction, so both these conjuncts have to be true. So it would be great if I saw that as a premise, because right away I'd be able to fill out three values, P, Q, and R, true, true, true. And then I'd go and wherever P, Q, and R appear in the other premises in conclusion, I'd putting all T's under them, and see what follows from that. See what assignment of truth values I need then to make the other premises true and the conclusion false. Okay, but look now, what I've actually got here by comparison, if that was a problem and I had that as a premise, I'd start with the premise in assigning truth values. Here, look, I've got a conditional as a conclusion. In the initial assignment, I made the conclusion false, because a counterexample is something with a false conclusion. And I know, since I know thoroughly my truth table for the hook, I know that there is only one way to make a conditional false. If the conditional is false, the antecedent must be true and the consequent must be false. So I have here two sentential variables that have their truth values determined, right? It's necessary. The necessity is important, right? True, false. Compare, for example, just to make it even clearer, if I had a premise that was not that, but this, P or Q or R, right? Say that's my premise, right? So, okay, initial assignment, I make the overall formula, which is this disjunction, I make it true. Do I start here? No, I do not start here. In what? In assigning truth values to the components. Why not? Because there are many ways, right? Because it is not the case that the truth value of the sentential variables is determined, given that this overall thing has to be true. There are many, many rows in the truth table overall where this comes out true, right? All I need is at least one of them to be true. They can all be true. Two of them can be true, and there's several combinations of that. One of them can be true, right? And there's three combinations. There's three ways that can be so, right? So no, that's no good. If that was my conclusion, on the other hand, of course, the conclusion would be false, and then this would be a good place to start. If that was my conclusion, this would be false. The only way to make it false is for all three of them to be false. So I would be able to say P, Q, R, all false, and I'd have three determined truth values, P, Q, and R, all false, if that was the conclusion, right? So you've got two elements, two bits of information you have to be very careful of. Right. One is if it's a premise or conclusion, right? So the conclusion here, because I've got a conditional here. Sorry, it's whether it's the two bits or whether it's a premise or conclusion. So because the premise is made true, but the conclusion is made false, and then just the truth table for each of those. So my point is to say, I'm going to start here with the conclusion, not because it's a conditional, because it's a conditional in the conclusion, which means that the conclusion that the conditional is false, because there's only one way for the conditional to be false. I wouldn't always start with the conditional. If that was my premise, if P hook Q was one of my premises, right? Well, the premises I make true, and then I wouldn't start there, right? Because there are three ways to make that conditional true. It can be true, true, false, false, right? The only thing I know is that it can't be true, false, right? Which is what it turned out to be in the modus ponens one. Okay, so that's why you got to be careful. You got to be clear on the semantics. That's basically the truth table. The semantics of the logical form you're presented with, and be attended to whether it's premise or conclusion, right? If that's a premise, you start here, but if that's a conclusion, you start with these variables. If that's a conclusion, you don't, right? Because the conclusion is false, then the conclusion you make false, and there's plenty of ways to make that false. About this, if this is a premise, don't start with that, because there's many ways to make it true, and you make the premises true. But if this is the conclusion, oh yeah, it's a good place to start in your assignment, right? It's a good place to start if that's a conclusion. There's only one way to make it false. Make them P, Q, and R are determined to have their truth values false. Okay, so what have we got? P, I'm going to start with this because the conclusion, it's a conditional. Conclusion has to be false to find a counterexample. That means P is true and T is false. So that's the case everywhere. So T is going to be false here. T is going to be false here. What else we had? P is true. So P is true. P is true here. And P is true here. Okay? All right, I'll come back and continue.